So in this chapter, in chapter 9, which is about trigonometric ratios, a lot of this content is based on what you should know from GCSE level. So I'm going to first of all assume that you know how to sine, cosine and tan to work out sides, side lengths and angles in a right angled triangle. Okay, if you feel like you need to brush up on that, I've got some links here, some videos to core bit maths and some practice questions you can do, which I'll post next to the video if you feel like you need to brush up on that. The other sections of this chapter are about the sine rule and cosine rule, which are also in GCSE, which you use for non-right angled triangles, but the actual questions are sometimes a little bit harder. So that's what this chapter is all about, basically. So we're going to have a look at sine and cosine rules separately, when you would use each one, and then some problems. So these are both the sine rule and the cosine rule. On the left, I've got the sine rule. On the right, I've got the cosine rule. Okay. Now, these letters in here, the lowercase letters always stand for sides. The uppercase letters always stand for angles. So if I was labeling this triangle here, if I called this side A, now the angle A is always the angle opposite, like this. Okay, so we do them in pairs like that. If this was side B, then angle B would be up here. And if this is side C, then this is angle C. Okay, that's how we label our triangles, and that's the format that these rules assume that you have labeled your triangle in. Now, if we look at these different formulae, the sine rule, we've got, you don't necessarily need to use all three parts of this. You would normally just use two, but it just shows that the ratio between the side and the sine of the angle is always the same. But we've got a side, an angle, and an angle. So this is going to be for either finding, maybe you don't know what A is, but you know two angles and a side. Or perhaps you're trying to find an angle and you know two sides and an angle. Okay. But the point is that we've got two angles involved here and two sides here. In the cosine rule, we've only got one angle, which is A. So this is more suited to triangles where there's only one angle that you know, or perhaps there's one angle that you're trying to find, but you know all three sides. Okay. I'd suggest you make sure you've got both those formulae written down somewhere, because I'm just going to have a look at a few triangles and we're just going to decide which rule we would use on each triangle. Okay, we're not going to do any calculating, I'm just going to decide which rule to use. So, this first one, well, we've got two angles and two sides, so this is going to be the sine rule, okay, because I've got two angles involved. If I labelled them, perhaps this could be A, B, B. So I could then use sine A over A equals sine B over B. Okay. Or I would have sine X over 8 equals sine 35 over 6. And then I could solve that to find X. Okay. I know that I've written this upside down compared to the original one, but that's fine. You can do it as a reciprocal instead. If you just flip both sides of your equation, that's perfectly fine to do. And that makes it a bit easier if you're finding an angle. Okay, this one I've got one angle, but then three sides. So this is going to be the cosine rule. Okay, because I've only got one angle, but I've got three sides. This next one, I've got two sides and two angles. So this is going to be the sine rule. This next one, I've got an angle, two sides, and then a missing angle. Sorry, a missing side. So this is going to be the cosine rule. Okay, because a squared is b squared plus c squared minus 2bc cos a. So here my angle would be here for a. This would then be lowercase a. This would then be b and c. Okay, so if you look at those variables, that makes sense that that's going to be the cosine rule. Okay, this one I've got two angles and two sides, so this is going to be the sine rule. I would set it up as x over sine 39 equals 9 over sine 72, and then I could solve that. Okay, this one I've got two angles and two sides, so again that's going to be the sine rule. I would set this one up as x over sine 48 equals 9 over sine 61, and then I could solve that. This one, I've got two angles and two sides, so again that's the sine rule. I could have x over sine 63 equals 7 over sine 79. This one I've got one angle and three sides, so this is going to be the cosine rule. So I'd set this up, let's just write down the formula. Now I've got to make sure my angle is labelled as A, because obviously that's the only angle in my formula. So that means that this side here is A. The other two don't matter so much. And now if I substitute my numbers into that, then I'll have x squared equals 7 squared plus 10 squared minus 2 times 7 times 10 times cos 35. And then I could solve that to find x. Okay, this one. I've got three sides and an angle. So this is going to be the cosine rule. And then this last one, again, I've got three sides and an angle. So that's going to be the cosine rule. Okay. Now I'm just going to go over a couple of examples as to how you actually carry out these calculations to work out the sides or the angles. So this is going to be the cosine rule. You can tell because there's three sides and only one angle. Let's write the formula. Okay. So we've got A needs to be this angle here, which means that's lowercase a. The other two doesn't particularly matter as long as you've got your B's opposite each other and your C's opposite each other, and that's fine. So let's fill these in. So I've got x squared equals 15 squared plus 12 squared minus 2 times B times C times cos of 115. Okay. Now this one I could probably type into my calculator basically like this. I can just type in the whole right hand side. So 15 squared plus 12 squared minus, and then in brackets, 2 times 15 times 12 times cos 115. Okay, and that'll give me x squared. Now I can square root it. So x is 22.8. Okay, there we go. If we've got a missing angle, let's just go over what we'd do here. So let's label the sides. We're missing this angle here, this angle alpha they've called it, but we will call it A. So then this is going to be side A. Let's call this one B. So that'd be angle B. This is C. That's angle C. So A squared, so that's going to be 4 squared, equals B squared. So that's 9 squared plus C squared, which is 7 squared, minus 2 times B, which is 9, times C, which is 7, times cos, and we're just going to have to leave it as cos A. I suppose you could write cos alpha if you wanted to in there as well. So to solve this, I'm going to do 4 squared minus the 9 squared and minus the 7 squared. That gives me minus 114 equals, and now we're left with just this, minus 2 times 9 times 7 times cos A. It's going to divide both sides by minus 1, and then I'm going to divide it by 2, divide it by 9, and divide it by 7. Okay, so that gives me 19 over 21 equals cos A. And then to find out what A is, we just need to do inverse cos of that. So you can do inverse cos of 19 over 21, which equals A. So that's 25.2 degrees. Okay. Let's have a look at some slightly more interesting problems. So here we've got a more algebraic problem to look at. So determine the value of x. Well, we've still got 3 sides and 1 angle involved. So it's still going to be the cosine rule. So let's just write down the cosine rule. Okay. We need to label it. So the angle has got to be A. Okay, there's my other sides. So let's fill this in. So A squared, so that's 2x minus 1 all squared, equals B squared. So that's x plus 8 all squared. Plus C squared, well that's x squared. And then minus 2 times B, which was x plus 8, times C, which was x, times cos 60. Okay, so there's our equation, and now we've just got to simplify this until we get to a point where we can solve it. Okay, so I'm going to expand all the things that can be expanded and see where we get. So 2x minus 1 squared, that's going to be 4x squared minus 4x plus 1. X plus 8 squared is x squared plus 16x plus 64. Then we've still got the plus x squared. And then we've got minus, let's just sort out what's in this bracket. I've got 2 times x plus 8 times x times cos 60. Let's do the algebra bits first. So I've got 2x times x, so that'd be 2x squared, and I've got 2x times 8, so it's going to be plus 16x, and then I've still got to times that all by cos 60. Okay. I'm going to move all of these algebraic terms here to the left, I think. So I'm going to subtract x squared, subtract 16x, subtract 64, and subtract x squared. So that will give me just 2x squareds, minus 4x minus another 16x, that's going to be minus 20x, and then 1 minus 64, so that's minus 63. Now the right hand side, cos 60, if you type cos 60 into your calculator, you'll find that it is 1/2. So actually all that I'm left with on the right, I've still got that minus, but instead of 2x squared, it will just be x squared, and instead of 16x, it would be 8x. Okay. So I've got 2x squared minus 20x minus 63, and that equals minus x squared minus 8x. Let's move these two terms to the left-hand side. So I've got 3x squared minus 20 plus 8, so it's going to be minus 12x, and then minus 63 equals 0. So we've now just got a nice quadratic. Okay. I'm actually going to divide it all by 3 as well to make it even nicer. So it'll be minus 21 equals 0. Okay. Now, just solve a quadratic however you like. You could even just use your calculator to solve it if you want to. This one definitely factorizes, but you can just use your calculator to solve a quadratic. So our two solutions are going to be x equals 7 and x equals minus 3. Now in the context of this problem, it's a triangle with side lengths, and one of the side lengths is just x. So it's definitely not going to be x equals minus 3. We're not going to have a side length of minus 3. So the answer here is just going to be x equals 7. Okay, this next one, this is a bit more of a problem in context. So it says Coast Guard Station B is 8 kilometers on a bearing of 60 degrees from Coast Guard Station A. Okay, for bearings, might have been a while since you thought about bearings, but the key thing to do with bearings is they are measured from north. So north is obviously straight upwards. So a bearing of 60 degrees, that would be about here, okay? And they're measured clockwise from north, okay? That's the important thing about bearings, clockwise from north. If we had a bearing of 270 degrees, then that would be like that. Okay. Now, in terms of this question, so Coast Guard Station B is 8 kilometers on a bearing of 60 degrees from Coast Guard Station A. So it's measured from Station A. So let's just draw Station A first. Okay, so that's down there. I'm just going to draw on north. Okay, so a line that just goes straight up, because then I can use this to measure my angles. Right, and Station B is on a bearing of 60 degrees. Well, this would be 90, 45 would be there, so I guess 60 is kind of in this direction. Maybe something like that. And it said the bearing is 60, so let's just label that angle there as being 60 degrees. And the length is 8 kilometers. Okay, that's the first sentence. Oh, and that was where Station B was. A ship, C, is 4.8 kilometers on a bearing of 18 degrees away from A. Okay, so a bearing of 18, it's obviously going to be much shallower angle. So maybe that's something like that. Okay, and the length is 4.8. So we'll pop that in there. Okay. So we know that this little angle in here is 18 degrees. And we know that the length is at 4.8 kilometers. Okay. And that's where the ship C is located. And let's just join this up to form a triangle. And the question asks, how far is C from B? So we've basically got to find this length here. Okay. So it's not a bad diagram. I think I'm going to redraw it though, just to make it a bit clearer, so I don't have that north line in the way. So something like this. I've got A, B, C. This was X. This length was 4.8, and this length was 8. In terms of the angles, if this is 60 from the vertical, and this little bit is 18, then that means that this angle in here must be the difference between the two. So 60 minus 18, so what's that, 42 degrees. Okay, and now it's just a regular cosine problem. So we can fill this in as, let's write down the formula. Okay, and it's even labelled right. A is already the angle, so that's handy. So we've got x squared is b squared plus c squared minus 2 times b times c times cos 42. And then we can solve this. So I'm just going to type this whole thing into my calculator. And I just need to remember to square root it. Right. So x is then 5.47 kilometers away. Okay, so sometimes these problems might be a bit more wordy, and it's just about drawing a useful diagram. Okay, and they do often talk about bearings as well, so it's worth brushing up on bearings if you need to. Okay, if you wanted to practice exclusively cosine rule, then you can have a look at exercise 9a, but I think I'd be tempted to just do exercise 9e at the very end, which is a mixture of everything, because the real skill is in picking which to use when. But if you do need to do exclusive cosine rule practice, that's 9a. Right, for the sine rule, so remember the sine rule was A over sine A equals B over sine B. And you could write equals C over sine C as well if you want to. But it's all to do with the ratio between the sine, the side, and the sine of the angle being the same for all of the pairs. Here, okay, let's label this as A, and B, and B. So I can have X over sine 85 equals 8 over sine 45. Okay, and I can solve this. So I'm just going to get X is 8 over sine 45 times sine 85. And let's see what we get, and we should be able to type that into your calculator in one expression too. So I get 11.3. It's most useful to use this format with the sides on top when you want to find a side. If you want to find an angle, it tends to be a bit nicer to put the angle on top, just in terms of rearranging your algebra. Okay. Right, here's another one with a side. Let's see if we can just do this straight away. So we've got x over sine 100 equals 8 over sine 30, because remember it's got to be the one opposite it. And then we can find x. So 8 divided by sine 30 times by sine 100. So it gives me 15.8. Okay, these two I've got to find an angle. So I'm going to actually put the angle on top in my equation. So here I would have sine A, if I label it like this, over 5 equals sine 85 over 6. So that means that sine A, or alpha as they've labelled it, would be sine 85 over 6 times 5. So let's work that out. Sine 85 divided by 6 times 5. So it gives me about 0.83. Now to find A, I need to do inverse sine. So A is inverse sine of 0.83. Which gives me 56 degrees. This next one, set up again, we'll do sine, this is a theta here, so sine theta over 8 is the same as sine 126 over 10. So sine theta is sine 126 over 10 times 8. Theta, well, rather than doing this as a decimal, to keep it as accurate as possible, I'm actually going to do inverse sine of this whole thing. You wouldn't necessarily need to write all this working, but because you could just type this into your calculator. But I just want to show you what I'm doing. So let's work this out. If I do that, I get 40.3 degrees. Okay, there we go. Again, if you wanted to do exclusive practice just on sine rule, you could have a look at 9b. Right. Something I want to talk about is the ambiguous case of the sine rule. So ambiguous obviously meaning it's not clear which type we mean. Let me explain. So suppose you're told that a triangle has got side AB, so the length from A to B, of 4, the length from A to C is 3, and the angle ABC, so that's the angle in between A, B, and wherever C is 44 degrees. What are the possible values of ACB? So that's the other angle in your triangle. Now there's two possible triangles that you could actually draw here. You could draw one like this, or you could draw one like this, and they could both have that length A to C of 3. And both of these triangles can exist because you could still have the sides are the same and this angle is the same. So you can either have this triangle here, or we can have this big triangle here. And they both obey all of the facts that you were given. So this is why it's called an ambiguous case of the sine rule. It's ambiguous as to exactly which triangle we're looking at. So the two different angles for ACB, so we're talking about that angle there or that angle there. One of them, in this case this one, will be an acute angle, and one of them will be an obtuse angle. So how do we work out which one we want? Well, you can either state that there's two possible answers, or they might tell you, given that ACB is an obtuse angle, or given that ACB is an acute angle, in which case you know which one to pick. How do we actually work them out though? Well, let's pick Let's just pick this triangle here, the smaller one. Okay, so this is 44, this is 4, this is 3, and this is the angle that we want to work out, so I'm just going to call it x. So I'd have sine x over 4 equals sine 44 over 3. So that would then give me, I'm just going to work this out as a decimal, sine 44 over 3 times 4. So 0.926. So then I could do inverse sine of that. And I get 67.9 degrees. Okay, 67.9 degrees, so that's an acute angle. So that's obviously corresponding to this angle here. Okay, so when my calculator's done it, it's given me that angle. But what if I want to work out this angle here instead? Well, if we think about the graph of sine x, okay, so the graph of sine x looks a bit like this. And we'll talk more about the graphs in the next couple of lessons, but this is the graph of sine x. We've got x in degrees on the y-axis, on the x-axis, sorry, and then y is the sine of that value. This is 180, this is 360, and this is 0. Now, when I put in sine x equals 0.926, bear in mind this graph goes between 1 and -1, I'm basically looking along here, okay, at about 0.926. So you can see there's two intersections. There's one here, and this is your first answer, 67.9. But then there's also one here. There's another solution. Now, if you look at this graph, it's symmetrical. So this gap here, which is 67.9 degrees, must be the same as this gap here, just because of the symmetry of the graph. So to work out the other angle, I can do 180 minus 67.9. And that will give me the alternate angle that I could have here, which is 112.1. So that must be the obtuse angle that we could have instead. So there's two different answers. To find the other one, we can just do 180 minus that answer. In fact, you could picture it, maybe if you sort of reflect this angle here, so this obtuse angle, it also appears in there. So you can think of it sort of in either way. And then there are angles in a straight line, which is also why it's 180 minus that answer. But I tend to think of the graph when I'm thinking about it. And we will think more about the graphs of sine, cos, and tan in the next couple of lessons as well. Okay, if you want to have some questions on the ambiguous case of the sine rule, have a look at exercise 9c. All right. So to find the area of a triangle that's right angled, that's easy. Half base times height. Okay, for a right angled triangle. However, when it's not right angled, we can use this formula here, half AB sine C. Now in this case, this is the angle C, so that's side C, and then this is going to be A, and this is B. Okay. So we're doing half, so in this case of this triangle, we're doing half times 3 times 7 times sine 59. Okay, so the area of this triangle would be about 9 centimeters squared. Okay. Now, in terms of remembering which sides are which, as long as you've got the angle in between the two sides, then that will work. Okay, so it always needs to be in this sort of pattern. So you've got the side, this angle, and this side. And then it's half this times sine of the angle. Okay. If you've got a triangle where you know lots of angles, then just be careful with that you don't use the wrong angle. It needs to be the angle in between the two sides. Okay. Right, let's have a look at these two questions. Right, the area of the triangle is 10. Find out what x is. So that means that half AB sine C should be 10. So for us, that's going to be half times x plus 3 times sine 30 equals 10. And we've just got to then solve this equation. So I've got half times x plus 3 times sine 30. Well, sine 30 is equal to a half. Okay. So I've actually got a half times a half in here. So that's a quarter. And then if we multiply this out, I'll get x squared plus 3x equals 10. So I'm going to have a quarter x squared plus 3/4 x minus 10 equals 0. So I've now just got a quadratic to solve. And then we can just solve this. So I'm just going to use my calculator to solve this quadratic. Okay, my two answers are either x equals 5 or x equals minus 8. And because we're talking about a side length x here, I think it just needs to be the positive value. So the answer is x equals 5. Okay, the area of this triangle is also 10. If theta is obtuse, so bigger than 90, determine theta. Okay, so we've got half AB sine theta, and the answer should come out to be 10. So half times 5 times 6 times sine theta equals 10. Okay, well, let's try and just get sine theta on its own. So sine theta is going to be 10 divided by 6 divided by 5 divided by half. So that is 2/3. Then to find the angle, I need to just do inverse sine of 2/3. So that's 41.8 degrees. But it tells me that it's obtuse. So think back to the graph. It says 1, minus 1, 180, 360, 0. I'm looking for 2/3, so I guess that's about here. You can see there's my two solutions. Whoops. There's the first one, which is 41.8. And here's the second one. So I need to do 180 minus that. So that's 138.2. And that must be our answer because it told us that it was obtuse. Okay. If you wanted to do some practice of areas, then 9D would be the one to look for. 9E is also a good exercise to do because this has got a mixture of sine and cosine rules, so you've got to pick which one to use, which is probably the hardest part. And it's also got some more sort of wordy problems in there as well, which is more likely to be the sort of thing you might get in an exam. Okay, so I'd recommend you have a go at that.